All right, we're going to take a few minutes today to go through a little bit more Algebra 1 review, writing equations of lines. We went through some of this in class already with talking about what equations of lines are. We covered section 2.3. I probably have a video about that somewhere too. So what we're going to do right now is we're going to focus on writing equations of lines. So there's some equations that are going to help us out as we're doing this. The first being the equation for slope. Okay, so I'm just going to bypass the whole rise over run thing and the change in x over the change in y. If you want to remind yourself that we're using this notation, delta x over delta y, rise over run. But that's the equation for slope right there. We are going to use what's called point slope form, which looks a little something like this. Okay, it says x1 and y1. Really, that's any point. Okay, x1 and y1, x1 and y1 come from any point. And this is a sloppy day for writing. Okay, you leave this y and this x stay as y and x so that you have your two variables in your equation. And then what we'll do is we'll work to put that into our old friend slope-intercept form, which is obviously y equals mx plus b. Before I go any further, I want you to notice that those two things are the exact same equation. Okay, a lot of students don't recognize that, maybe because they're never really, it's not pointed out to them. But if we multiplied both sides of the slope equation by that denominator, it would become point slope form. That's where point slope form comes from. So let's take a look at what we got going on down here. It turns out that some of these are going to be pretty easy. Like this first one here gives us the slope and it gives us the y-intercept. So all we need to do is write our slope-intercept form. Point slope form is not needed. And that's it. Second one says given the slope and the point 0.9, well, this is up to you. Here we were nice and reminded you that's the y-intercept. You need to notice that any point that has an x value of 0, that is a y-intercept. So we again have a pretty straightforward example here. A couple quick reminders I'm going to put up here about parallel lines. Parallel lines have same slope. Perpendicular lines have slopes that are opposite reciprocals. Opposite reciprocal slopes. We're going to need that too. So let's take a look at what we got going on down here. It says write the equation of the line given a point and the slope, or given 2 points. So if you're given a point and a slope, you can go right to your point slope form. This is basically x1 and y1. So we're going to go y minus 7 equals our slope, -2, times x minus -3. We don't leave it like this. We're going to distribute that -2. Get -2x minus 6. Careful with the negative, obviously. And now we'll add that 7 over. Get -2x. -6 plus 7 is +1. There's our slope-intercept form. Okay, next one is much the same. Just got to deal with some fractions. We have y minus -4 equals the slope times x minus 6. So 1/3 x minus 2. And then we'll subtract that 4 over. Again, if you ever need to just pause the video and go back, feel free to. I'm not going anywhere. Okay, the next one, we don't have the slope, so that's the first thing we're going to find. So we'll take y minus y, 4 minus 7, x minus x. Make sure you're starting from the same point in the numerator and denominator. 4 minus 7 is -3. Denominator is -9, so our slope is 1/3. So we have y minus, now in this case we can choose either of those 2 points, it doesn't matter. I'm just going to arbitrarily pick that second point. Y minus 4 equals 1/3 times x plus 4 minus a negative. We're going to distribute that 1/3. And then the last thing we're going to do, we're going to add 4 over. So what I'm going to do is I'm just going to say, I'm going to add 4 to that side. When I add 4 to this side, make it a useful 4. That still says 4. I just got a common denominator right away. So our final equation is going to be y equals 1/3 x plus 16/3. Last example here. This time I'm going to go 10 minus 5, just change it up a little bit. And negative 14 minus negative 15. And that's going to give us our slope of 5 over 1, which is just 5. So we have y minus, again, you can pick any point. I'm just going to pick that second one. And we just put it in slope-intercept form by solving for y. All right, so now we're going to find equations of lines given whether they're parallel or perpendicular to a specific line. Here in this case, the line that we're working with relation to is negative 4x plus 1. So first, we're going to find a line that is parallel to it going through negative 3, 5. So if it's parallel to it, what does it mean about its slope? Yeah.
It's going to have the same slope.
Going to have the same slope. Okay, so we know that our slope is going to be, I'll just write right away, the slope is going to be the same as that line, so negative 4. We can just go right into point slope form. Y plus 5, because it's y minus negative 5, equals negative 4 times x minus negative 3. And then we distribute. Careful with that distribution, with that negative. And then we're going to subtract 5 from both sides and have negative 4x minus 17. Two lines are parallel if their slopes are the same and they have different y-intercepts, which these two lines have. If their slopes are the same and they have the same y-intercept, what is true about the lines? If their slopes are the same and they have the same y-intercept, it's the same line, right? It's just the same line. And maybe you're probably thinking, well, how wouldn't you know that? Well, they could be in different forms. Maybe one's in standard, maybe one's in slope-intercept. And you don't realize until you start piecing things together. All right, part B, what do we need to use as our slope then? If they're perpendicular. Anybody, say it. 1/4, the opposite reciprocal, 1/4, good. All right, so little fraction practice here. We love fractions in here though. Y minus negative 5 equals that 1/4 times x minus negative 3. We'll distribute that 1/4. Okay, when I subtract 5 over, I'm going to right away get a common denominator of 4. So I'm going to subtract that 5 over, but I'm going to put it under, or over 4, I should say. What should my numerator be? 20. There, that still says minus 5, right? Cool. 3 minus 20, remember you don't subtract your denominators, it's just you subtract the numerators. 3 minus 20 is negative 17/4. Good? All right. I like this next set. It seems like pretty straightforward at first. Write an equation of the line that goes through the point 1, 2, and is parallel to x equals 3. Well, what kind of line is x equals 3? It's a vertical line. So think of the line that has to go through 1, 2. I'll just do a little sketch here. Here's 1, 2. That's got to be a vertical line. right? It's got to be a vertical line because it's parallel to x equals 3. So it's also going to be an x equals equation. It's going to be x equals 1. So this one is more conceptual than it is algebraic, like with actually, solving through a formula or something. It's more conceptual. Okay, now this one says perpendicular to y equals 5. For this one, I'm actually going to put the y equals 5 on here. Y equals 5, 1, 2, 3, 4, 5, is a horizontal line, right? If it's perpendicular to it, what type of line does it have to be? Vertical. So what's our answer to this one? It's got to go through that same point again. It's going to be x equals 1 again. It's the same exact line. Again, conceptual. It's getting you thinking about what's happening with the different information that you're given there. Okay? Bless you. That's on video. You've been blessed forever now on YouTube. Yes. All right, we're going to shut it down now, though. Have a great day.